Welcome to another video in the ARIA tutorial series by ExoTools. In this particular tutorial, we're going to be covering the property view. The property view shows you various properties of the network nodes that are inside of your network. To ensure that you see the property view, you can go under the Views menu, and there is the property view. If it's hidden, it will say Show Property View. You can select the tab there. The property view responds to the selections within the shape view. So if I were to select a node, the property view loads the necessary information about this particular network node, including its type, etc. So this network has all of the different types of network nodes that we currently support: primaries, incrementals, zips, and combinations. So we're going to go over the property view for each node type, including splits as well. So here I have a symmetrical primary node selected. You can see that the network node type is a primary node. It gives you the long base name of the node as well as the short base name of the node. There is currently no alias for Browfurrow. It gives you the file path for the OBJ file that would be on disk, and this also gives you and denotes whether or not this path is valid if it finds an OBJ in this path. And then this icon here is to toggle between the environment variable or the full path. This tells us whether or not the node is enabled. When you build, any nodes that are disabled will be ignored by the build and will not wind up on the blend shape node. If I were to turn off enable here, you would see the enable turn off, and bidirectionally, if I turn it on here, you would see it turn on there as well. Since we have the ability to reference ARIA networks, this particular network is not referenced. This is the build rule. So we're using the symmetric mesh during the build. We have another tutorial on what using the build rule is all about. And then from here, we get into more of the specific kind of containers of information that are different per network node. So in this particular case, Browfurrow has splits left and right. So if I were to open up split map data, I could see that we've got our split node. It shows us the full split map file, and this would give us an icon on whether or not the split map file is not valid, or if it can't find the file or cannot find the network. And then for every single node type, we have the ability to associate tags so that if you're using or want to tag certain network nodes, you can create new tags and assign those tags, and you can also search by a tag name. You could also make notes as a modeler on exactly what is happening with this particular shape, or you can import an image or GIF animation images here as reference for this particular shape. Let's move on to a split node. So under Browfurrow, we have a split node here. You're going to see a lot of the similarities between network nodes. So again, this is the long split map name is right. The short would be R. This gives you the actual name of what the split node would be when it gets built. So this is Browfurrow right. This is Action Unit 4 right. This is the current split map file that it is using. Remember that in our split map tutorials, there's a decoupling between the naming convention that's used and the actual map that you can use for the splitting. It gives you the map file path. So this is the map to the actual file that you're currently using. And then this is the OBJ file path, just like in the symmetrical node. Again, we have enable and reference. Let's move on to incrementals. So under jaw open, we have here, if I were to select jaw open and it has both incrementals and zips, you could see here, we have a lot of the same information. So all the way down into the build, during build use, the build rule is very much the same for every primary. And then down is the specific containers per primary node. So jaw open has a number of incrementals. So if we were to open up our incrementals container, you can see that you can select the different incremental that is available, and it updates the UI here to kind of give you an idea of what's happening per incremental. And then you can edit this live as the incrementals are live. Once the network is built, you could use this interface inside the property view to change the incremental trigger to move the curve around and adjust things, and you would be able to see the results live. We also have zips. So these are the different zip nodes that are inside of or working with the primary. You can see jaw open zip and open sticky zip. You might also be hiding the zips. So if you turn the zips off, you can at least get an understanding from here that this primary does indeed have zips. We'll turn the zips back on. And jaw open, as we can imagine, is involved in a number of different combinations. And so in ARIA, the terminology is downstream dependent. This is just an independent combination node, but if you're dealing with a primary that influences a number of combinations, those combinations live downstream in the network, hence the terminology downstream dependence. If I were to open that up, I could see all of the combinations downstream that jaw open is involved in. And if I were to notice that jaw open is also being driven. So over in the status column here, if I were to roll over this status column, I get a tooltip that jaw open is indeed being driven by something. So we will open up the drivers container. And if we look at this, the jaw open shape is indeed being driven by the jaw joint. This gives us the ability to invert the skinning through the shape. This is the channel on the jaw joint that is actually driving the jaw shape. And then this is our remapping grid here. So that means that when the jaw rotation in X is at 0, our shape value is at 0, but when the jaw rotates in X 36 degrees, our shape value will go to 1, so that as the jaw rotates, our shape will be increasing in value. You can also set the driver to the end value, to the start value, and mess with the curve here live as well, just like with incrementals. Let's move on and go to our last node type, which is our combination. So if we select a symmetrical combination, we could see here that we've got a little bit different information. There's some additional information on combinations past the build rule. This shows us the combination level. So this is a combination with only one set of upstream drivers, so that'd be a combination 2, and then you would get combination 3, 4, and so on. The input weight mixer is what algorithm is used by the flex solver node to mix the input weight values of the driver node. So this is not the combination solver math. This is how to mix the different input weights into the combination before the solver looks at what the final weight on the blend shape node should be for that particular combination node. So in this case, we have multiply, smooth, and max. Smooth is the default. This particular combination is set to multiply. And then we have, because we are on a symmetrical combination, we have the ability to run something called update combination split targets. So you can see underneath this combination shape, we have this split target shape, which is jaw open, lip upper razor right, which means jaw open is combined with the right split node of lip upper razor. This would be the left split node of lip upper razor. And so very much like incrementals and zips are children of primaries from a network node perspective, the split targets, combination split targets are very much children of the symmetrical. So when you are dealing with upstream drivers that are split, we need to split the combination to reflect those upstream split drivers and put those on the blend shape node. If things change upstream, you can always hit update combination split targets for ARIA to create the correct permutations of the split targets based on the upstream nodes. Speaking of upstream nodes, we also have something here for upstream drivers. This shows you the list of driver nodes that are driving this particular combination. And we also are able to show, again, downstream dependence. Now, one of the nice things about being able to do and list these out is we always have a right-click menu and we can select that node. So let's go to this larger combination and right-click and do select node, and that loads and finds the combination for us and then changes the property view. You can see in this combination level 3 combo, we have 3 combinations that feed into this combination. If I wanted to see the entire upstream structure in the property view, I can uncheck this show direct drivers only checkbox, and that would give me the full list of all of the network nodes that are upstream to this particular combination node. So that is a overview of what you see in the property view. No matter what you select, the property view will update to kind of show you the information that you need to understand exactly what's happening in the network. Thanks.